Hello everyone. In this lecture, we are going to talk about types of data. What are the different types of with respect to big data, with respect to the landscape of big data, right? Normally, if you talk about data, it can be of different types, right? Even big data is a type of data. Then you have structured, semi-structured and unstructured data. You have time-stamped data. You have machine data, right? You have spatial data. Spatial data is with respect to space, with respect to your location. Temporal data is data separated by time, taken at different time. You can have spatio-temporal data where both the dimensions are included, location as well as time. You can have open data, publicly available. You can have closed data. You can have real-time data. You can have non-real-time data. There are many types of data. You can go into quantitative types, you can go into qualitative types. Types of data is going to change with respect to the background in consideration. So while we talk about big data, we talk about three main types of data: structured data, semi-structured data, and unstructured data. The content is present in this is taken from this book, Fundamentals of Business Analytics. In that, there is a separate chapter just written by R.N. Prasad and C. Acharya. So, whenever the university opens, you can check out this book from the library. Yes. Coming to the types of data again, with respect to big data, we talk about structured data, we talk about unstructured data, and we talk about semi-structured data. So in this lecture, we're just going to talk about structured data. And lastly, there is one little factor also involved in this, called as metadata. So metadata is basically, very short and term to remember what is metadata. It is data about data. Whenever you have to explain metadata, you can use this. It is data about data. For example, this video, the lecture which I'm going to make, it will be around 50 to 60 MBs in size. So that is data. But the captions which I'm going to use, right, the title which I'm going to use, name of the file, all of those words, they are representing what that 50 or 60 MBs of file is all about. So those captions become metadata. Similarly, with respect to a file, Excel file with 10,000 records, if you name it and then choose the name of the columns and depict that so and so data is stored in this file for so company under these columns, under these categories, then those categories, the name of those categories, it depends, it becomes metadata. Supposedly you are sharing a HTML page, the structure of that page is represented in XML. That XML becomes the metadata. Metadata is always data about data. So your key central entity is going to be your core subject, your raw material. Whatever you are going to use to elaborate on that data, or to put it into context, whatever addition you do to enhance the quality of that data or to serve some specific purpose, that data is called as metadata. Talking about the distribution of digital data, this data is the digital data is classified under this categorization. Out of 100, we have nearly 80% of data as unstructured data. 80%, right? So it is a huge number, and it basically represents that we have a lot of images and videos that are going around in the world. In the last 5 years only, the boom in the smartphone industry, the boom in the camera industry, there are so many pictures, there are so many devices which are generating data, and most of that data is unstructured in nature. So And also, why it is encompassing 80% of the area is because that data is huge in size also. It is constantly being updated, constantly uploaded, be it your videos, be it your Twitter accounts, or data with respect to your Facebook post, data with respect to sensors. All of that data is constantly generated, and in most of the cases the size of the data is also large. It is not small, it is not kbs in size. In the same context, if we talk about structured data, which is hardly 10%, if you are going to check the records, a normal Excel file, if that file has 1000 records, it is still going to be like 200 kbs in size. That's small, right? So with respect to size, we have a smaller share in this distribution with respect to structured data, because the records are stored in a structured manner. They are stored in a tabular format in most cases, and storing data in that is quite easy for our storage formats. But when we talk about unstructured data, even one image is going to be 5 MBs in size. I click a photograph, my one photograph is 5 MBs in size, right? And if I take out a detailed file of all the contacts in my phone, so if I have 2000 contacts in my phone, I am going to hardly get a document worth 200 300 kbs in size. So if you see the value associated with respect to both the things, 5 MBs for one photograph, which I might delete also. I might be having 15 same photographs of the same portrait, and I might delete rest of them. They don't even matter, but the space is occupied, the resources are used, and it will be used in processing also whenever I want to do that. But in structured data, right, I have 2000 contacts in a file of size 200 to 300 kbs. So the composition is small, but the maximum amount of information is derived from structured data only. This 10% is with respect to the use of data. Again, if we're talking about distribution, that includes the use of data, that includes the generation of data, that includes whatever you are operating on. What is the percentage? If you take out randomly a sample of data, what are the chances that it is going to be structured, semi-structured, or unstructured? 80% of the times it is going to be unstructured in nature. Lastly, we have semi-structured. So this is going to involve both of these, semi-structured as well as structured as well as non-structured data. A combination of both of these, both the structured as well as unstructured data, is called as semi-structured data. We will be covering structured data over here. Again, if you go back over here, we're talking about types of data with respect to big data, right? And we talked about the distribution of data. We talked about the introductory aspects of all of these, what is metadata, and how all of this digital data is distributed across the storage media, across the internet, across the devices. Talking about structured data. What is structured data? Just try to think about it for a moment. Structured data. If you just try to dig out the details from the name, structured data is that type of data which has a structure, right? Water does not have any structure. We'll take the structure of the container you're going to put. But apple has a structure, your bananas have structure, your oranges have structure. They are going to have similar type of make. They're going to have similar type of a model. You can demonstrate a model that an apple is going to look like this, and all of the apples are going to fall into that category. In structured data, we say that any type of data which has a well defined structured, right, that data can be considered as structured data. If we go into more technical definition, structured data is that data which adopts a type of data model which has very well defined structure, right, which follows a very consistent type of ordering, indexing and searching, updation, deletion. Everything is very consistent and neat in manner. Structured data is also associated with schemas. So if you have covered database, you might be knowing what a schema is. If you've not covered it, I will just give you a brief introduction about schema. Schema depicts the representation and distribution of data across a relational database. Relational database is, it combines a lot of tables. Tables are going to combine a lot of rows and columns. So you have rows and columns which are making tables. Then you have tables which are associated with a particular structure. That structure is referred to as schema. So when we talk about structured data, it mostly conforms to a particular schema. We can simply say that this structured data follows so and so schema, right? We totally understand what is going where, how it is being stored, which type of data we will find in which column, how to apply a normal query. Everything can be done. And mostly we talk about tables, we talk about relational databases in the terms of structured data, and that makes processing really easy because you have data in two-dimensional form in tables. Those tables are connected in another dimension that is different. Those tables can be easily used to search, to index, to update, to delete, to answer your questions, your business related questions. Everything can be simply done. And in most of the cases, we use SQL to do that. SQL is your structured query language. It was particularly, designed to take out information out of those databases. Now we're going to talk about characteristics of structured data. So first one is, again, it conforms to a data model. Some sort of model must be there which is going to portray or outcase that how particular data will be stored. If data is coming from X source, then data must go to table X1. If the data is coming from Y source, then it must go to table Y2. Before storing into Y2, so and so operations must be done, and then the data will be stored in this format. Everything is done with respect to a particular data model, right? Because our end result, we know what our end result must look like. We know that our data should look, should fall into these rows and columns in particular format. If this column is going to store numbers, then it should only store numbers. If the name column is going to have words and characters, characters A to Z, no number is allowed. Names column, then no number will be allowed. So very particular data model is used to store your structured data. Second point is, data is stored in the form of rows and columns. Example, relational databases. So yes, in structured data, the data is stored in the form of rows and columns, 2 by 2. There can be as many rows as you want. There can be as many columns as you want. With respect to columns, if you have 10 columns or if you have 100 columns, those columns are going to decide the categories, right, of how you're storing your data. And your rows are going to decide your transactions or your records or your entries. So if you are making a relational database for sale in Walmart, you might be having like 10,000 entries in a day with name, what the person bought, how did he or she pay, did he or she get her own bag, or whatever. Columns can be multiple, so many columns, depends on you. And entries will be depending on your use case. Relational database, again, relation refers to this table of rows and column. We don't call it table in computer science, we call it a relation. A database which consists of many relations or tables is called as relational database. Third point, data resides in fixed fields within a record or file. So your fields are fixed. If alphanumeric is allowed, alphanumeric is allowed. If the entry is taken as yes or no, it is taken as yes or no only. If the entry is defined, that only 4 options can be chosen, then only 4 options can be chosen. If you have to put your card number, they are going to ask you about a 16-digit number. No other number is acceptable. So the data is going to be put into fixed fields, and those fields can be a simple record, a simple transactions, or it can be an entire file. Next point, definition, format, and meaning of data is explicitly known. So we know what we are storing, we know what is the format which we are using, and we know what is the meaning of that data which we are storing, right? So you are going to define that this column is going to contain names, this column is going to contain the mode of transportation, the mode of transaction, and we know what format we are going to specify. Will it be 0 1 or yes or no or A or B or C? And we know what is the meaning of that data because we have decided it. So all of the things are known beforehand. We design a model depending on that, use tables and columns with a very fixed representation of records or files, and that is how your structured data is stored or presented for that matter. Next point, attributes in a group are the same and similar entities are grouped. If you consider both of these points, what they are basically saying that similar entities can be grouped. You can take a smaller portion out of that table, you can snip out the sections which you want, you can group together the columns which you want, everything can be done. You can group together the columns which are similar, you can combine whatever columns you think are same or similar in nature or contradictory in nature, complementary in nature, may be affecting one another, may not be affecting one another, right? For example, name of a person does not have anything to do with respect to the card number of a person, right? They are going to be random. That association between the name of a person and the number of his or her card is going to be randomly chosen, but it can be verified by the bank. So you know that 2 columns, they are not dependent on one another in any matter, but if you talk about the pattern of income of a person and the expenditure of a person, there you can find an association. There you can identify which person is earning how much and how much he or she is spending, what are the products he or she is spending on. Then you can combine the columns to see if there are patterns which are present or not. But again, very limited, very simple, everything is very sorted out with respect to structured data. And these are the characteristics of structured data. Coming to sources of structured data. So what are the sources which generate structured data? We have databases, we have old databases, 20 years old or 10 years old or 5 years old databases. And a database is not like a simple file. For example, the AWS details form which all of you filled, that cannot be considered as a database. But if I combine that form with the previous forms which were filled by all the candidates across the university, then those files can be combined, those tables can be combined to create a database. Similarly, I can go further in future to predict the demand, or maybe I can go back in time to see how many students accessed the credit, access the resources. So those sources of data, databases, they are considered as structured data. Spreadsheets have a lot of data. Spreadsheets are also generated all across the world with respect to any type of data they want to create. If they want to store data in tabular form, do plus and minus, calculate, make results, whatever they want to do. So spreadsheets are again a good source of structured data. SQL is again structured query language which is used to operate on data. So if you're using different queries to be run on your data, that is also going to generate structured data. And lastly, we have OLTP systems. So OLTP stands for online transaction processing online transaction processing systems. There are two types of systems when we talk about big data or whenever we talk about data mining or warehousing. One is OLAP and the second one is OLTP. OLAP is online analysis processing, where you are analyzing your data. The database will be standard and your work will be to analyze the data. On the other hand, we have OLTP, which stands for online transaction processing. Whatever transactions are happening, if they are constantly being upgraded and updated into a relational file, into a table of rows and columns, then that database, the system which is collecting that database, is called as OLTP, online transaction processing system. All of the industries which are selling products, be it your bookstores, be it your meat vendors, be it your milk vendors, they must use OLTP systems to record their transactions, and that is a very huge source of structured data. So you have different databases, you have spreadsheets, you have SQL based databases and their associated queries, you have OLTP systems, you have Excel files, you have online forms which are generating data, you have web pages which are generating data, you have network logs which are generating data, web server logs are there, we have sensors which are generating data, we have medical devices which are generating data. So if a machine is there and the format is particularly specified that when once MRI is done, the data will be stored in so and so format. So it falls under the category of structured data. Apart from these, four, we have more categories. You just think about it and you can put it on paper. Then comes the ease which is associated with structured data. Why is it so easy to operate on structured data? It is easy to store structured data because again, it is going to be really rich. You can store thousands or millions of records in a very small file. Storage of structured data is really easy, and this can be better understood by comparing it to unstructured data, right? Storing images, that is a very big task, but storing a normal file in the forms of rows and columns, that is not a very daunting task. So structured data is very easy to store. Scalability, you can easily scale, because if you have a Excel file, it will not stop at 100 records or 1000 records. You can go as large as you want because it is very easy to store those files. So you can simply scale up your data within those files. So scalability refers to the trait of expanding. For example, if I have a virtual machine with 4 GB RAM, but I need to have a virtual machine with 6 GBs of RAM right now, right? Or maybe I have a storage hard disk drive, virtual storage hard disk drive of 100 GBs. and I want 150 GB right now. Normally, what is going to happen? I will have to buy that drive and all. But with respect to cloud, what is going to happen? On the go, I will be allotted a 150 storage drive virtually. That storage will be connected to my account. So I have scaled from 100 GBs to 150 GBs. Similarly, from 4 GB RAM to 6 GB RAM, I can easily go. My RAM is scaled on the go from 4 GB to 6 GB. That is the meaning of the term scalability. And with structured data, you can easily scale. You can go from 100 records to 1 lakh 1000 records, or you can go from 100 tables to 10,000 tables. You can go from 10 databases to 150 databases. It is really scalable in nature. It is secure, yes, because you can simply apply any type of cryptographic technique on your data, right? You can use changing hashes because you know what is the schema of your data. The person who is going to attack has no idea how you have used the schema itself to encrypt your data. It becomes more secure. Structured data can be stored with more security. Updation and deletion. Updation and deletion is very easy. You can simply find a record, delete it, or maybe update it, or insert other record at that place, because it is structured in nature. You can simply find a query. Search operation is very easy to do on structured data. Then why is it easy to retrieve data out of structured data? Very easy to retrieve. If you talk about retrieving information, again, that example where we are mapping the income of a person to the expenditure of a person, if you can find some association with those columns, that will be retrieving information. That out of a record of 10,000 customers, we found out these 200 customers whose salary is in so and so range, and who spend so and so percentage of their salary on Walmart. So those customers can be issued a special card for their transactions because we want to maintain loyalty in them. That is retrieving information, and that is very easy to do when you have a database. It is very easy to index and search, again, because it is orderly in nature. You can simply search. You can use your sorting and searching algorithms to search through your data. Data mining is easier because you can find out information. Yes, so mining data is easier with respect to structured data because you can easily find out what you're looking for. You can run different queries involving maybe 10 parameters or maybe 15 parameters. With structured data, it is easier to do. Then if we come to BI operations, business intelligence operations, similar thing. With data mining, we might be looking for specific traits or specific results, but with business intelligence operations, we might be looking for things which we do not know that they exist. Maybe some association is there with respect to buying one product and the other product out of an inventory of 1000 products. So manually it is not possible to find out the associations, but if you run self-learning algorithms which can find out the association, then the industries or the companies might be surprised that if X product is bought, then Y product and Z product and A product is also bought by the person. So those business intelligence operations can be easily executed with the help of structured data. Next is unstructured data, which we will discuss in the next lecture. Again, the questions which can be there, which can be asked with respect to this, is what do you understand by the different types of data with respect to digital data, with respect to big data again? So you have structured, unstructured, semi-structured, and metadata again. Just write it down in the last section because again it is important. What is the distribution of all of these data? What is the meaning of structured data? What are the characteristics associated with structured data? What are the benefits associated with structured data? What are the sources of structured data? And how it can be used. All of those things also we discussed over here. Structured data can be used to retrieve information, for indexing, for searching, for mining data, for executing BI operations. Thank you.